one of the things you're expected to understand in high school algebra is how equations represent graphs and how you can understand more about the graph based on the equation and vice versa. This question is asking two main ideas. First of all, where are the x-intercepts located? Do you know how to do that? Second of all, at those x-intercept locations, does the graph bounce off of the x-axis, like you see in some places, like right here, or does it cross the x-axis, like in some cases over here? Which one of those behaviors happens in this equation? So if you've had some experience with graphing polynomials, you may just need a refresher. We'll see how that goes. But I want you to think about these equations, all of these equations over here, in a certain way. If you have the value 0 and you multiply it by another number, what do you get? Okay, you just get 0. 0 times anything is 0. So this is why we have something called the zero product theorem, and it helps us find x-intercepts if you have an equation in factored form. So if I were to just look at this equation right here, this is not the correct choice, by the way. If I were to just look at that, that says x-intercepts are located at the place where x plus 1 equals 0. That makes that whole parentheses equal to 0, which makes y turn into 0 when you multiply it through. X minus 2 equals 0, and x plus 3 equals 0. This is what the zero product theorem tells us. And this gives us certain x locations. Okay, x equals -1, x equals +2, and x equals -3. Well, if you look at the graph, those are x-intercept locations right here. So we think we're doing pretty good. We need something that has x plus 1, x minus 2, and x plus 3 as the factors. And those give us all the x-intercept locations. So I think we can cross out some of these things. Right? Some of these things are just silly now. And now the ones we have left all have x plus 1, x minus 2, x plus 3. How do we figure out which one of these represents the graph? Well, we need something called multiplicity. Multiplicity. Great. Okay. Multiplicity is basically the exponents. Okay. So the exponents of the graph tell us what it's doing at these places. An exponent that is odd, like 1 or 3 or 5, is crossing. Odd equals crossing. Even exponents like 2, 4, 6, and so on bounce. Now we could get into the reasons why they bounce and the reasons why they cross. That's a little bit more of a lengthy discussion, but I'll just leave it at this. Things that bounce are basically parabolas. They look like quadratics. They have this shape to them, okay? And anytime you see an exponent that's squared, it's going to look like a little bit of a parabola right there. And I'll show you where the parabola is in our picture. It is right here. That is a tiny little parabola. If you were to just zoom in on just that part of the graph, like right here, you would see it looks like a tiny little parabola at that location. So that tells us whichever one of these factors was responsible for the x-intercept at -1, and I'm gonna use a different color here to try to really narrow down what I'm talking about. This x-intercept is caused by this factor right here. Okay, that means that factor has to have a squared associated with it, which is this polynomial right here. And the other two factors, if we check, they both have exponents of 1, which means they are crossing, not bouncing.